Imagine your application's memory is a high-end restaurant. Every object in your app is a table, and you have a garbage collector robot, which is a cleaner that comes in regularly and clears tables that are no longer in use. But here's the rule. It is only allowed to clean tables that are not on the active list. Now, a customer finishes eating and leaves, but someone forgot to remove that table from the active list. The cleaner looks at it and says, looks like the table is still in use. So it just walks away. That table stays dirty and unused forever, taking up space. Then it happens again and again. Eventually, your restaurant is full of dirty, unused tables. New customers try to enter, but there are no tables for them, and your restaurant crashes. Yes, you've just experienced a memory leak in the restaurant. In unmanaged languages like C or C++, a memory leak happens when you forget to manually free memory. In C#, we have the garbage collector that automatically deletes unused objects for us, which is good for us. But it's obedient. If you, the developer, accidentally hold a reference to an object that you no longer need, the garbage collector will never delete it. Let's look at the two most common ways we accidentally reserve memory forever. Let's say a user visits your dashboard page. ASP.NET Core creates a new dashboard controller. Now, the user leaves the page. In normal cases, the controller becomes unreachable, the garbage collector cleans it up, and our life is good. But now, plot twist. You inject a singleton service. This service leaves for the entire lifetime of the application and subscribes to an event like onPriceChanged. Now, the user leaves the page. The garbage collector wants to delete the controller, but it checks references and says, hold on. The singleton service still has an event subscription pointing to this controller. So this controller cannot be disposed. And the snowball effect happens. Another user visits the dashboard. A new dashboard controller instance is created, and another event subscription happens. The user leaves, but the garbage collector cannot delete it. Then, another user refreshes the dashboard page. Yep, new controller instance and another subscription, and the garbage collector cannot delete it. And 10,000 requests later, the singleton service is now holding 10,000 dead controllers in memory. Memory keeps growing. Performance degrades. Eventually, you get out of memory and the app crashes. How do we fix this one? Unsubscribe from the event inside the dispose method. ASP.NET Core automatically calls dispose at the end of the request. So when the user leaves the page and the controller is no longer needed, the dispose runs. What does that achieve? Once the event is unsubscribed, the singleton service no longer holds a reference to the controller. The controller becomes unreachable. The garbage collector can now clean it up. Now let's talk about another classic memory leak. Static. Anything static leaves until the application shuts down. When there's static objects in your app, the garbage collector sees it and says, this must be important. I'll never delete it. Now imagine this. Every time a user visits your homepage, you add something to a static list. Let's say one string is approximately 100 bytes. 1,000 requests become 100 kilobytes. The app runs fine for weeks. When it reaches 10 million requests and becomes 1 gigabyte, then it suddenly becomes slow, then finally crashes. This is why memory leaks are so scary. They're slow and delay. You might have the feeling like, what? Why suddenly out of memory? But of course, there's also the fast death version. Imagine instead of strings, you store images in a static list. If one image is approximately 5 megabytes, 200 requests become 1 gigabyte. 1,000 requests immediately crash. Your server dies within minutes of going live. So is static evil? Should we not use it? No, we just need to use it properly. Static is great for things that never change, like a list of 5 fixed table column names that you want to stay in the app and be shared with all users. Just don't use it to store data that grows endlessly. Make the static be static. Now, have you ever noticed this? When the app was acting weird, then I restart it and now it's fine. Why does that work? Let's visualize your server's RAM as a kitchen sink. In a healthy app, you wash dishes like processing requests in the app. The water drains away, like the garbage collector frees up memory. And the sink stays mostly empty. A memory leak is like putting a stopper in the drain. You keep washing dishes. The water keeps rising. Nothing breaks immediately when there's still remaining memory, so everything looks fine for days, maybe even weeks. But eventually the water spills onto the floor. That's your out-of-memory exception. Now, when you go to Azure or AWS and click Restart, it's like dumping the entire sink out and starting with an empty sink again. Everything works perfectly now, but just for a while, until the sink slowly fills up again and out-of-memory happens again. That's why restarting isn't a fix, it's just buying time. The real fix is finding the leak, like the event that was never unsubscribed, or a static list that keeps growing forever. Fix it, remove the stopper, and the sink can finally drain. And if this video helped you understand memory leaks, hit that like button, subscribe for more, and I'll see you in the next one.